In this video, the functionality of the ROS2 motion primitives from trajectory controller with the corresponding UR hardware interface is demonstrated. For this demonstration, a UR10e robot is used. Instead of sending a trajectory to the robot, as is common in ROS2 control, individual motion primitives are sent and executed directly by the robot controller. Sending motion primitives instead of a trajectory makes the real-time requirements on the ROS2 side less critical. It also has the advantage that the robot controller has a better understanding of the robot's dynamics. The controller receives the trajectory computed by MoveIt and approximates it using motion primitives. There are currently two options for this, either an approximation in joint space using linear joint primitives, also known as PTP or MoveJ, or an approximation in Cartesian space using linear Cartesian primitives, also referred as lin or MoveL. Both approaches use the Armour-Douglas-Peuker algorithm. This shows how a trajectory planned as a lin motion with the Pilz planner is reduced to a single lin primitive. On the right, the planned path is shown in blue and the approximated path in orange. The coordinate frames represent the target poses of the lin primitives. The entire motion is thus approximated by a single lin primitive. On the left, the joint trajectories are shown, and on the right, the position of the end effector for both the planned and executed motion. The planned motion is shown in blue, while the executed motion is shown in red. Both plots indicate only a minor deviation. It is also possible to stop the motion. Here the same is shown for a PTP trajectory generated by the Pilz planner, which was approximated in joint space using a single PTP primitive. On the left, the joint positions of the planned trajectories are shown in blue, and the target positions of the PTP primitives, representing linear motion in joint space, are shown in orange. On the right, the joint trajectories for both the planned and executed motion are displayed. Here as well, the deviations are minor. This is where it gets interesting. Using the OMPL planner, a collision-free path around the obstacle was planned and then approximated using PTP primitives. Note that the Grippo is not considered here. On the left, it can be seen that the trajectory was approximated using 3 PTP primitives. On the right, the deviations between the planned and executed joint positions are shown to be small. The same is done here using lin primitives. The motion was approximated using 10 lin primitives. On the left, the joint trajectories are shown, and on the right, the end effector positions of the planned and executed motion. Deviations can be observed here, but they remain within acceptable limits.